Now we want to be able to find limits at infinity of trig functions. So here we have the limit as x approaches infinity of sine of x. Now if we look at the graph of sine of x, we can see that it just keeps oscillating between -1 and 1, and so there's really no horizontal asymptote to the sine of x. So this just keeps going up and down. Okay. So as x approaches infinity, sine of x oscillates between 1 and -1, so the limit does not exist. We always know another way we can write this is that sine of x is always greater than or equal to -1 or less than or equal to 1. So this wasn't totally fruitless though, because if we look at this next function, we have the limit as x approaches infinity of sine x over x. We already know this information right here, that we know the sine of x is less than or equal to 1 and greater than or equal to -1. So what we're going to do in this inequality is we're going to go ahead and add an x in here, and we're going to divide all of these actually by x, and we know that doesn't change our answer. Okay, and so what this tells me then is that the limit as x approaches infinity of -1 over x is going to be less than or equal to the limit as x approaches infinity of sine x over x, and that's going to be less than or equal to the limit as x approaches infinity of 1 over x. Well, the limit as x approaches infinity of -1 over x is 0. And the limit as x approaches infinity of 1 over x is also 0. So if we think about this, it's kind of a weird thing. We know the limit as x approaches infinity of sine x over x has to be greater than or equal to 0 and less than or equal to 0, and so we know this limit actually equals 0. So let's take a look at this graph and verify that that is what's happening. So here is our function, and you can see it's oscillating back and forth, but it is getting closer and closer to 0 as we get closer to x equals infinity. Alright, so we do have our horizontal asymptote at y equals 0. Alright, and that's finding limits at infinity of trig functions.